All right, welcome to your 2.4 notes, or your 2.4 notes part 2. So we'll be discussing even and odd functions. So if we take a look here, a graph is said to be symmetric to the y-axis when our point xy and our point negative xy are points on the graph. So for example here, you'll notice we have our point 2, 0, and we have our point negative 2, 0. So we have a negative xy over here and our point xy here. So if a graph is symmetric to the y-axis, it is known as an even function. So to test to see if a function is even, we substitute negative x into the function for x to see if it yields f of x. So if f of negative x equals f of x, then it is an even function. This is our little rule right here. So we can test this out. Let's say we have our example, let's say f of x, what we have up here, f of x is equal to x squared. So to test to see if it is an even function, we'll just insert ignore that, f of negative x equals, and then we have negative x squared. And we know that negative x times negative x is going to give us a positive x squared. And so because it yields our f of x, we know that this is an even function. Right, so the next page. So for our first example, I guess, we have is f of x equals x squared an even function? We definitely just did this. So we're going to simplify substitute negative x for x and then simplify. We just did this, but if we just point out on the graph, remember if it's an even function, our point xy, we also have a point negative xy. So just going through this again just to emphasize what is going on. So our function f of x is equal to x squared. Substituting our negative x in to test to see if it's an even function. F of negative x equals negative x squared. We know that negative x times a negative x is going to give us a positive x squared. So because it yields our f of x function, we know that it is an even function. So if we graph this out, just to kind of show, we have our point 0, 0, and we have 1, 1. So 1, 2, 3, and 4. 1, 4, or 1, 1. And then we also have 4, 2. Or 2, 4. Oh, excuse me, I'm thinking the square root. So we have the point 2, 4. Alright, so if we go up like this, we know it's symmetric across the y-axis. So we have our point 1, 1 here, and 2, 4. So we know because of this rule up here, we're going to have points negative x and y. So if we have a negative 1, and then we go up 1, and then we have our negative 2, and then an up 4. So basically, symmetric across the y-axis. So if we take a look at another example here, or actually moving on to what an odd function is, a graph is said to be symmetric to the origin when we have our point xy, and then we also have a point negative x, negative y, and these are both points on the graph. So if a graph is symmetric to the origin, it is known as an odd function. To test to see if a function is odd, we're going to do the same thing as we did with the even. We're going to substitute negative x into the function for x to see if it yields negative f of x. If f of negative x equals negative f of x, then it is said to be an odd function. So key point right there as well. All right. So if we move forward, we have our first example. Is f of x equals x cubed an odd function? So how are we going to prove this? We're going to substitute negative x in for x and then simplify. So we have our f of x function is equal to x cubed. So proving this, we insert f of negative x. So we have negative x cubed. We know that any negative number cubed is going to be negative. So this is actually negative x cubed. All right, and you'll notice that x cubed is our function, x cubed, and we have a negative. So what we have here is our negative f of x. So if we yield our negative f of x, then we know that this function is odd. All right. So just plotting a quick little graph of this. All right, we have our x and y axis. If we just create a couple points, so 1, 2, 3, 4, 1, 2, 3, 4. All right, let's pick a couple points. 0, if we plug 0 in, we're going to get 0. So we know that's kind of basic. So if we plug in our point 1, so 1 cubed times 1 cubed is going to give us 1. Oh, I'm sorry, excuse me, I keep looking at this function. We're looking at our original function. So 1 cubed is 1. So this is our point 1, 1. And then if we look at 2, we know that 2 cubed is 8. So 4, 5, 6, 7, 8. So this is going to be all the way up here to 8. Alright, so just kind of drawing our graph like this. And because we know that it is an odd function and that it is symmetric to the origin, we know that our points we have x, y, and then we know that our negative x, negative y exist. So if we just take our points, we're going to have a negative 1, negative 1. And then if we look at this point up here, we're going to have a negative 2, negative 8. So 5, 6, 7, 8. So this is just a rough sketch of what our graph is going to look like. All right, so if we move on to our next example, we need to determine whether or not the function is even, odd, or neither even or odd. If it is even or odd, we're going to sketch out the graph. So let's take a look here. We have f of x equals x to the 5th plus x. So what we're going to do is we're going to insert negative x in for x. So f of negative x is equal to negative x to the 5th plus x. This is going to give us any negative number to the odd power is going to be a negative x to the 5th. Oh, excuse me. This should be a negative x. We inserted negative x. If you can't tell, this is one of my first times making a video. So we have our negative x here. So we have a negative x to the 5th minus x. We can pull out a negative from here. So if we pull out a negative, we're left with x to the 5th plus x. And if you'll notice, this x to the 5th plus x is the same as our function. And so we have right here negative f of x. So we know that this is an odd function. Because we know this is an odd function, we know that we have points x, y, and it's symmetric to the origin, so we have negative x and negative y as well. So if we plot this out, just a quick little graph here, we have our point 0, 0. We're looking at the original equation. And then if we just plot, let's say 1. So we have 1 to the 5th is 1, plus 1 is 2. So we have our point 1, 2. So we'll plot that out. So this is 1, 2. And just, this is going to be kind of a really rough sketch. And because we know this is odd and symmetric to the origin, we also have the point negative 1, negative 2. So negative 1, negative 2. So we'll just plot that out. And that's just a really rough sketch of our graph. Moving on to our next example. We have, or once again, we're determining whether or not the function is even, odd, or neither. And then if it's even or odd, we'll sketch it out. So we have g of x is equal to 1 minus x to the 4th. So what we're going to do is we're going to insert negative x in for x. So g of negative x is equal to 1 minus, we have negative x to the 4th. Any negative number to an even power is a positive number. So we have this is equal to 1 minus x to the 4th. All right. And if you'll notice, 1 minus x to the 4th is our original function. So this is equal to f of x, which lets us know that this function is even. And what do we know when the function is even? Is that it's symmetric to the y-axis. And that our points, we have points x, y, and we also have points negative x and y. So just drawing a quick little graph of this here. We have our x and y axis. So plotting our first point, so if we want just our y-intercept, we put 0 in for x, and that gives us 1. So if we have 0, 1, That's our x-intercept. All right. And also if we just plot the point 1 on both sides. So 1, if we plug 1 into the equation, we know that 1 minus 1 to the 4th is 0. So this is 1, 0. So we'll plot this here. And because we know that this is an even function, it's symmetric to the y-axis. So we know that we also have the point negative 1, 0. So plotting that accordingly as well. And that's just a rough sketch. Right. Moving on to our next example, we're trying to determine whether or not the function again is even or odd or neither. And then sketching the graph. So we have h of x is equal to 2x minus x squared. So if we insert our negative x to prove whether or not it's even or odd, we have h of negative x is equal to 2 times negative x minus negative x squared. All right. So just simplifying this out, this is equal to negative 2x, and negative x times negative x is a positive x. So we have minus x squared. All right. So you'll notice that it looks almost close to our function up here, but not quite. We have a negative 2. We have a negative in front of the 2x. So if we try maybe pulling out the negative, we have a negative that leaves us with 2x plus x squared. You'll notice that this still does not look like our function above. So we know that it's neither even or odd. So this is neither, and we can't sketch this out. And then moving on to number 6. Once again, determining whether or not the function is even or odd, or even neither. So we'll take a look. We have j of x is equal to have 2x cubed minus 4x. So let's just insert our negative x into the equation and see what we get. So we have j of negative x is equal to 2 times negative x cubed minus 4 times negative x. So this is going to give us any negative number cubed is a negative number. So we have 2x cubed, or negative 2x cubed, and then a negative 4 times a negative x gives us a positive 4x. All right, so if we try to take out a negative number, because right now this doesn't look like our function, we're adding the two terms together and there's a negative out in front of the 2. So if we try taking out a negative, we have a negative that gives us a 2x cubed minus 4x. And if you'll notice, this looks like our f of x, and we have a negative out in front. So this is equal to negative f of x. So this tells us that our function is going to be odd. All right. We can draw a rough sketch of this, but if you'll notice, we have a little graph here. So you'll notice we have, at 1, we have negative 2. And up here we have 1, 2, I think this is going to be 8. I think they did these by 2, so this might even be 4. Either way, you'll notice that the graph is symmetric to the origin. So I think that's going to be the end of our notes for today. If you could go through example number 7, I'm going to be looking to see that that's done when I come around and check your notes tomorrow. And otherwise, we'll go through 2.3 tomorrow in class. So have a nice night.